So in this problem, we need to show that cosine theta minus sine theta is square root of 2 times sine theta whenever we have cosine theta plus sine theta given by square root of 2 cosine theta. So let's begin. So we'll start with whatever is being provided to us. So here we are given cosine of theta plus sine of theta. So this is equals to square root of 2 times cosine of theta. Now we're going to divide both sides with a cosine of theta. So we'll have 1 plus sine theta over cosine theta equals to square root of 2. So sine theta over cosine theta, that's the tangent function. So we have tangent of theta equals to square root of 2. So tangent of theta can be also expressed as square root of 2 minus 1. So we will come back to this in a moment. Now we'll start from the left hand side. So on the left hand side we have cosine theta minus sine theta. So we need to show that this is equivalent to square root of 2 sine theta. So for this, what we'll do, we'll take cosine theta as the common factor. So taking cosine theta as the common factor, so we have 1 minus tangent of theta, since we have a sine over cosine here, which becomes tangent of theta. Now in place of tangent of theta, we can replace this with square root of 2 minus 1. So we have 1 minus square root of 2, so minus of minus 1 will become positive 1. This is going to give us cosine of theta whole multiplied 2 minus square root of 2. Now from 2 minus square root of 2, we're going to take out square root of 2 as the common factor. So we have square root of 2 multiplied to cosine theta whole multiplied to square root of 2 minus 1. Now we'll finally replace the value of square root of 2 minus 1 with tangent of theta. This is going to give us square root of 2 times cosine of theta times tangent of theta. And what's the value of the product of cosine theta times tangent of theta? That's sine theta. So that means this is going to be equals to square root of 2 sine theta, which is the expression on the right hand side. Hence we have successfully showed that the left hand side equals to right hand side. Hence proved.